Ladies and gentlemen, a very good evening to you and welcome to the Institution of Mechanical Engineers and to this manifestly very popular lecture this evening. My name's Stephen Tetley. I'm the Chief Executive of the Institution. It's the second of our series of Shell lectures being done with the Institution and Shell. Anyway, welcome to this lecture this evening, and what we're looking to do is to really showcase the enormous global challenge that there is to engineering challenge there is to decommissioning, and particularly in the UK. I'm not going to talk something about much at all now. You'll hear much more about that later. But what we are looking at is something in the region of a £47 billion global issue over the next 20 years. And the engineering challenges are absolutely immense. But then again, as in all great engineering challenges, the opportunities are also immense too. So I hope it's going to be a really, really interesting evening to you. And I'd just like to introduce our two speakers. Alistair Hope is Project Director for Brent Decommissioning for Shell. Alistair is Project Director for Brent Decommissioning, one of the largest and complex projects in the North Sea today. Alistair has nearly 24 years professional experience in Shell. That's both in upstream, downstream, gas power, and in various research roles. He's worked in the Netherlands, Norway, the Philippines, and UK, and his experience covers all aspects of oil and gas project development, as well as operations, maintenance, new business development, and HSE roles. He's, I'm delighted to say, a chartered engineer and has a PhD in materials engineering from Cambridge. I'd also like to introduce Duncan Manning. Duncan is Brent Decommissioning Business Opportunity Manager for Shell Upstream International, and Alistair will be our first speaker. Duncan joined Shell in 2013 after 19 years of service in the Royal Marines, from where he retired as a Lieutenant Colonel. He had a very varied and successful career, which saw him fulfill a number of appointments, as well as selection and attendance at the United States Marine Corps University for a period of study there. He completed 3 operational tours in Afghanistan and was responsible for planning and delivering a national-level specialist response during the 2012 Olympic Games. In addition to a degree from the University of Aberdeen in Geography and International Relations, Duncan also holds a master's degree from the US Marine Corps University. He is a fellow of the Chartered Management Institute, where he's also qualified in strategic direction and leadership. So, Alistair and now Duncan, we very much welcome you here and look forward to your talk. After your talk, we'll then gather on the stage and there'll be plenty of opportunities for questions. So, Duncan, welcome. Thank you very much.
Thank you, Stephen, and thank you for the opportunity to provide a presentation to you tonight on what is for Shell the largest decommissioning project that Shell has ever undertaken, and as Stephen said, amongst the largest in the North Sea. As I joined the project 3 years ago, the parallels between Brent Decommissioning and the Olympic Games were increasingly evident the longer I stayed in the project team. I'll tell you what they are at the end of the lecture and kind of keep it on a knife edge. This is a large and complex decommissioning project, and it's large and complex for a number of reasons. Firstly, the location of the platforms in the northern North Sea, difficult to get to. Once you're there, actually you're constrained, particularly for overside work, by a narrow weather window to operate in. It's also complex because, unlike many decommissioning projects which are required to work on one platform at a time, we've been asked to submit one decommissioning programme for all 4 platforms. But it's not just all 4 platforms, it's all 4 platforms, 154 wells, 28 pipelines, 2 subsea locations. And those 4 platforms are 3 different designs. So you can see from the slide here, 3 of the platforms are gravity-based structures, or GBS, and 1 is a more traditional steel jacket. The fact that there's 3 different designs in the 4 platforms means effectively each platform needs to be looked at individually. The complexity is also added to the fact that the platforms are at a slightly different stage of their end of field life. So you can see here that Brent Alpha, Bravo and Delta have ceased production, but Brent Charlie continues to produce. I flew off on Brent Charlie a fortnight ago, and the size and complexity really hit home on that flight out. An hour flight north of Shetland on a helicopter, you start to overfly Brent Alpha first of all, and at the time it had the second largest semi-submersible crane vessel just off the platform, in fact dwarfing the platform, conducting a change out of the crane on the platform and removing the production module, ready to start the reservoir isolation campaign. We then flew over Brent Bravo, and it was conducting at the time a very successful plug and make safe campaign, again isolating that reservoir. And then we landed on Brent Charlie, still a producing platform, but starting to focus on what it needs to do to get the platform ready for efficient decommissioning. And on the horizon, just within eyeshot is Brent Delta, which at the time is going through the process of preparing itself for that lift that you saw in the film, and also conducting the Atacol recovery. So all 4 platforms are actually a hive of activity, and are at maximum capacity and have been for a number of years. So there is real complexity here. But it also provides an opportunity. The opportunity is to learn as we move between the platforms and become better and more efficient as we move between off Brent Delta, which is the first to be lifted, and then on to Bravo Alpha, and in time Brent Charlie. And because it is so large and complex, it's one of the reasons we've spent such a long time engaging externally, engaging with stakeholders to understand their views. We've engaged with over 180 organisations, and over 300 one-to-one engagements have been conducted. I've travelled the length and breadth of the country to conduct these one-to-one engagements, to understand what the views of stakeholders are, to allow us to explain what we are doing, what we plan to do, and gain their insight and understand their concerns as we move forward. We've also conducted, as you can see here, 14 wider stakeholder events where we've had all the stakeholders in one room, explained what we are currently doing and what we plan to do, and again, let them listen to the views of the other stakeholders in that room, because of course, each stakeholder, whether it's an academic, a Quango, a government organisation, a fisherman or an environmentalist, will all be looking at the project through their own lens, and some of those lenses are quite different. And of course, we know that there's unlikely to be one solution which provides a one-size-fits-all proposal which is going to be acceptable to all of our stakeholders. So it's finding that middle ground which is important to us, and that's the importance of these wider stakeholder events. You can see here we've also spoken at a number of conferences to ensure that the lessons that we're learning in Brent Decommissioning are passed both to the other operators but also to the supply chain, so that others get the benefit of what we've been doing in the Brent project. We divide decommissioning effectively into 2 components. The top part are those where there is pretty clear guidance or regulation in place, and it's really up to the operator to conduct the activity as safely and as efficiently as possible. So the first part of that is to isolate the reservoir from the surface, to plug and make safe each of the wells. And whilst it's only one small element on this slide, this is the activity which actually takes up the vast majority of the time in decommissioning terms, but it also accounts for most of the spend in decommissioning terms. Alistair is going to talk a bit more detail about the topside removal, but also the Atacol recovery. But the bottom part of the slide are those elements of decommissioning where the operator has to make a recommendation to the regulator through public consultation to determine what, on balance, makes most sense, and what, on balance, is the recommended option to push forward for decommissioning. And that's a phase that we're at the moment. So we need to make a recommendation for what to do with all of the Brent Alpha jacket, what to do with the drill cuttings, what to do with the pipelines, those 28 pipelines, but also what to do with the gravity-based structure, both the structure themselves, but also the contents of those structures. This is a thorough and robust process where we not only take those 5 factors given to us by the regulator, but we've also subdivided these into 12 sub-criteria. And you can see here that we work our way through a process of engaging both internally but also externally, gauging and getting the insights from the best minds in the industry to allow us to pull together all the data which will help make that recommendation. A key component for us in doing that is that independent review group. You can see in the middle right-hand element of the slide here. This independent review group, 9 eminent scientists and engineers led by Professor John Shepherd, provide the scrutiny of the science and engineering which underpins our recommendations to make sure that this isn't us making the science up to suit our own ends, but actually everything we do can be validated through this independent review group process. Of the 300 studies that we've conducted for the project, it's generated thousands of comments from the IRG which we need to respond to and close out before we move forward. And this isn't just a data gathering exercise of data in and data out. Actually, the other key component for us is, you can see the kind of second to last slide, is that engagement with stakeholders to understand whether the output from that comparative assessment process, is that acceptable, does it meet their needs, and does it provide the output which is likely to be acceptable wider as we step into public consultation. So breaking this down into the components of the project, the first of which is the Brent Alpha jacket. The Brent Alpha jacket is over 31,000 tonnes. It therefore is a candidate for a derogation, i.e. we can seek an exemption from the OSPAR convention, which is aiming for a clean seabed. We've done the studies on the Brent Alpha jacket to understand whether it can be lifted in one piece, and the answer is no, it can't. So therefore the focus is the second, the deeper component, the footings which anchor the jacket to the seabed, and how difficult it would be to remove that, and understanding the pros and cons associated with the removing of that of those footings. And you can see the footings in the photograph of the thicker sections of a jacket, which, as I say, anchor the jacket to the seabed. And our options are either to dig down into the seabed, excavate and then cut the footings, or bore through the tops of these footings and do an internal cut. On balance, our comparative assessment indicates to us that actually leaving the footings in place makes most sense when you weigh up the technical difficulty associated with that cut, and then remove the safety impact of the operation to conduct that, and the large cost associated with it, versus the very small both environmental and safety impact of removing it. The second component with the drill cuttings and the pipelines. The drill cuttings are those shards of rock which are generated during the drilling phase of the platforms, and in mid-1990s these were lubricated with an oil-based mud. Post-mid-1990s it was an oil-based mud, but regardless, the drill cuttings were discharged over the sides of the platform and are therefore accumulated at the base of the platforms, mostly either on the GBS or have fallen down into the fissures in the GBS itself. And the conclusion we've come to, again, balancing all those 5 options together, is on balance, leaving the drill cuttings in place makes sense. The majority of our drill cuttings sit underneath the threshold determined by OSPAR, and that threshold indicates the level of hydrocarbon leach rate which is acceptable. Most of our drill cuttings are below that. For those that are above it, we've done a comparative assessment, which again indicates that leaving the drill cuttings in place and not disturbing them actually on balance is the right thing to do. Of the 28 pipelines in the field, these vary in size from 3 inches up to beyond 30 inches in diameter. And these are either laid on the seabed or buried under the seabed. And each pipeline has been looked at individually to determine what on balance is the best option for those. And there was 9 options looked at. I won't talk about those in detail, but we've come to the conclusion that actually there is a range of proposed options for us to carry forward. And that's carrying forward with both a qualitative and a quantitative comparative assessment proposal. We're also mindful that we need to de-link ourselves from the export pipeline for those platforms, those non-Brent platforms upstream of us that need to maintain their export pipeline and allow them to continue to export oil and gas. And so there is a separate project which will do that bypass and allow the other platforms in the northern North Sea to continue to extract oil and gas and export that to shore. Whilst there is over 470 installations in the UK continental shelf to be decommissioned, a small proportion of those are gravity-based structures, GBS. You can see here 9 operational in the UK. And these are very large structures. The legs themselves are over 170 metres high, over a metre thick of reinforced concrete, over 300,000 tonnes in weight for each of the GBS. This has generated a lot of focus for us to understand how difficult it would be or how easy it would be to refloat these GBS. As a reminder, these platforms were put in place in the mid-1970s with a lifespan of 25 years, 40 years ago. Refloating them wasn't a consideration at the time, so we spent a lot of effort to understand whether it is technically possible to do that. And the conclusion is that whilst it may be technically possible to refloat them, actually the technical complexity associated with that, the very high safety risk associated with that, the very high cost associated with that doesn't outweigh the minimal environmental impact of leaving inert concrete and steel on the seabed or the very small safety hazard of leaving the legs up. We have also done separate studies on cutting and lifting the legs, but also conducted engagement with the key stakeholders in this respect, which is the fishermen, and their preference is to leave the legs up. What you can see, you can avoid. This is a conclusion other operators have also come to, and whilst the proposal is to leave the gravity-based structures up and the legs in place, we will of course ensure that the legs are both marked on maritime charts, marked in the fisherman's fish-safe system, but also we have aids to navigations which will be on the top of the legs to ensure that mariners are safe at all times. We have done a separate study to understand what the risk, the collision risk on these platforms is. And it's about 1 collision every 10,000 years, so well under a LARP, and that assessment was made on some very conservative assumptions. You can see also on the slide that there is littered around the UK coastline a number of other legacy, both industrial and military structures, not dissimilar to the legs on Brent. One of our probably more unique elements within Brent Decommissioning is the contents of the gravity-based structures. You can see here that the structures themselves have 64 cells. These cells are about 60 metres high, about the same height as Nelson's column, and about 20 metres in diameter. And again, much like the legs, these are nearly a metre thick of reinforced concrete. And the cells were used to store and separate the crude oil during the production phase. And it was during that production phase that sediment has effectively settled at the base of the cells. We know that the cells not only contain attic oil at the top, a layer of water and the sediment, but also a ballasting layer of gravel, which is used to hold the structures in place whilst they were positioned. A key component for us in engaging with stakeholders is to understand that sediment issue, not only understand quantity but also understand composition. And we made a commitment to stakeholders that we would not move forward with this issue until we had a sample. This has been an area of specific focus for the Brent Decommissioning team and also for our stakeholders. And it was for that reason that we generated the Cell Management Stakeholder Task Group, 15 members of our closest stakeholders to focus specifically on this issue. Driving this to a conclusion, a key component for us was conducting that sampling process. And you can see here, whilst we did have a number of attempts to gain samples, we were successful in the summer of 2014 conducting a cell sampling program, gaining access to 3 of the cells on Brent Delta, not only gaining access but also extracting samples of both attic oil, water and sediment. And that process was independently witnessed by Bureau Veritas, who witnessed the process of sampling, witnessed the process of holding those samples, but also the movement of those samples back to shore and then on to an independent laboratory, SGS. The analytical program we developed was developed not only with our own internal experts, but also agreed with the independent review group and had comments provided to it by the members of the CMSTG. So a very thorough and robust process to understand the composition quantity of the sediment, which allows us to understand what its impact is if it was to be left in place, but also what the technical challenges associated with the other removal options. And what the output from the sampling project was that we have 4 meters of sediment in those cells, and those 4 meters of sediment equates to about 1,000 cubic meters, and this is about 25% sand and grit, about 25% oil, and about 50% water. There's no trace elements of norm and trace elements of heavy metals. So this is, generally speaking, kind of oily sand, which is at the base of the cells. You can see here the output from the comparative assessment, having looked at the 5 options that we explored in detail, was that on balance, leaving the sediment in place makes more sense. We know that because of the very small environmental impact, in fact, a kind of negligible environmental impact that would occur if the sediment was to be released, but also understanding the challenges associated with getting it into the cell, mobilizing the sediment, extracting it, moving it to shore for processing. A process which in itself would generate lots of CO2, come with immense technical difficulty and safety risk. So whilst this has been a specific area of focus from our stakeholders, generally speaking, this is a conclusion which is accepted by the majority of the stakeholders. I'll now hand over to Alistair to talk about 2 of the kind of more exciting elements of the project.
Thanks, Duncan. The field was discovered in 1971, first production in 1976. To get the field into service that quickly, we needed some of the best engineering and the best engineers available at that time. And I'm going to illustrate a couple of examples where that's exactly the same today for decommissioning. We need great engineers and we need innovation and people thinking of new ways to decommission these facilities. We talked about the attic oil, the oil trapped in the tops of the cells, and taking the lessons we have from the cell sampling project, we've developed with a small company in Aberdeen a fairly lightweight deployable unit. This thing weighs about 3 tons, can be deployed from the platform using a remotely operated vehicle, so no divers involved. This is put on top of the cells. It provides a base plate from which we can use to drill through the meter thick of concrete and then deploy either a pump onto the top of that cell to pump out all the oil from each individual cell. We collect it in one cell and then come along with the tanker and evacuate it from there. So in this way, we're able to fairly cheaply and safely take away that attic oil and bring it to shore for proper treatment and disposal. So this is very much 2 small Aberdeen-based companies developing technology to solve this relatively unique problem, but very fast, innovative, cheap, efficient and safe. At the other end of the scale, we've got a company like Allseas, who've developed the pioneering Spirit, which is probably the largest vessel in the world, nearly 1 million tons by displacement. This is going to come into the field and lift off the Brent Delta topsides in a single go and transfer it down to Hartlepool, where it will actually transfer the topsides onto this barge, which is called the Iron Lady, and then that barge will come into the estuary and into Able UK's facility. So we are the first customer to sign up to use this vessel. Shell and ExxonMobil did a huge amount of technical assurance on this, and we continue to do a lot of technical verification on this, both the design, the seaworthiness trials, test tank modelling, and we will do a test lift later this year on a simulated platform that weighs about 5,000 tonnes. In each sort of step-by-step verification of this technology. We looked at 130 sites around the UK and the North Sea to bring the topsides to, and we eventually selected Able UK on Teesside based on their track record, their safety track record, their environmental track record, and the fact this is a very heavily industrialised area, so you're not creating noise or dust or trucking material through communities. In all cases, we had to invest in the facilities. So in this case, we have to create a super strong key. So there's about 1,200 piles that need to be piled into the clay to give us a firm foundation to put the 24,000 tonnes of Brent Delta on top of it. So once we bring in the Brent Delta, skid it onto the quayside, we'll go through a three-phased operation. Firstly, we'll make the thing safe. We'll then have an open house where we will invite people who've worked on Brent Delta and their families, but also the local community can come along and see what we're going to do. People can say goodbye to it, because many people have worked their entire 40 years out there on the platform. It is a second home to them. Once we've done that phase, there's a soft strip phase where Able will remove any materials that can be reused, take away hazardous materials like asbestos and dispose of those properly. And then finally, they bring the thing down on the ground as quickly as easily as they can and break it up with machines into scrap size coupons, which we'll then sell on. So I hope that illustrates some of the engineering challenges. We need innovation, we need creativity, we need great engineers to help us do decommissioning in a safe, environmentally responsible and efficient way. I'll hand back to Duncan.
So I said at the start that in my mind there was parallels between this project and the Olympics, and in my mind they were kind of size, scale, complexity, a difficult environment to operate in, but also a requirement to engage with a wide range of stakeholders to understand a diverse range of views. Where we are at the moment is we are about to step into that public consultation phase, setting out our recommendations in a written decommissioning programme to allow a public consultation phase to take place. That'll be 60 days long. We've doubled it from the normal 30 days, really to allow members of the general public to have a chance to really read and digest what we're proposing, and then come back and ask questions. We believe that we have gone through a very thorough process not only from backed up by sound science and engineering, but also through robust and elongated stakeholder engagement to really understand what the views of those most likely to be impacted or those who have an interest in the project are going to be. And what we've come to is a solution which we do think is robust and meets the needs of as many of our stakeholders as possible. But really, we're onto that next phase now of public consultation. Throughout the process, we've been independently verified by the IRG, and have had to develop new, novel technologies to overcome some unique problems associated with the project, but also some of the generic problems which other operators are going to have, and it's up to us to ensure those are passed on to the rest of both the operators and the supply chain. We've had a really quick canter through what would usually take an hour and a half to give a presentation in depth. But more than happy now to hand over to Stephen to allow some questions to be asked.
Well, Duncan and Alistair, thank you very much indeed for a very quick canter through, but nevertheless a really interesting insight into the challenges that are confronting you. And first of all, I'd like the audience to perhaps show their appreciation in the normal way. And perhaps you'd come and join us and take some questions. Now, we've got some roving microphones available, so I'm going to probably take one or two questions at a time, if that's okay. And of those of you who are asking questions, if you can wait till you've got the microphone, And then perhaps if you could state who you are and why you're here. But I'd like to just kick off with a question myself, if I could. You mentioned that this was groundbreaking and new technology, and you emphasised that quite a lot through your presentation, and it was obvious to many of us in this room the scale of the challenges ahead of you. And you then mentioned that Professor John Shepherd is heading up a team of experts in the independent review group. So how does because it's all groundbreaking and new technology, how can us ordinary members of the public be reassured that this independent review group actually knows what it's talking about and give us that level of assurance? Who's going to start?
Well, I think you could actually, I can see Professor Bill Dover there, who's one of our IRG members in the audience. Perhaps we could ask him, in fact.
We've read numerous documents from the consultants and the contracting engineers, and we've given our best views. There are 6 of us in this group, coming from all over Europe, with backgrounds in every aspect that you would want. And we have pushed Shell to improve the work at every stage. You know, if we think they haven't done enough, we ask them to do more, and we try to make sure that they've done the right thing. So it's been quite a thorough business lasting, 6 or 7 years now, that we've been asking questions and getting answers. So, I mean, we've done our best. We can't reassure you completely that everything is perfect, but we've done our best. Thank you.
I think indicative of the level of effort we've gone to, I mean, the extracting samples from the cells is one of those areas where it took a number of attempts to gain access to the cells. And if you can imagine, this isn't just a case of deploying a bucket down a well and taking a water sample. We've had to deploy tools over the side of the platform, penetrate through a metre-thick reinforced concrete, which is 85 metres under the sea, drop down 60 metres into the cell, and then extract a sample which has validity when it goes to a laboratory. As I say, there's been a number of attempts to do that, but indicative of how challenging that has been, we actually had to go to we went to NASA. And we have a technology partnership with NASA, and now NASA have a miniaturized sonar which they use for checking the internal integrity of lines on the space shuttle. They adapted this for our project and flushed it into the cells on Brent Bravo in order to capture a sonar image of the inside of the cell. That's the kind of level of effort that we've gone to give you an indication that we have really reached out outside the normal oil and gas sector to try and find solutions to problems which do require real innovation to overcome.
Interesting. Thank you. Right. Well, thank you for that. Thank you for the answer there, gentlemen here.
Hello.
Thank you.
Yeah, it is working. David Gresham from Arup. Now that you've been through the decommissioning process, almost all the way through for Brent Delta, in terms of the amount of effort's been required, where do you think there are potential cost savings for future decommissioning? More really outside of plug and abandonment.
Okay, let's just part that question. I'll take one more question, and now the gentleman here. Thank you.
Hi, it's Stuart Russell from the Government of Western Australia. I'd just like to get some indication as from woe to go or go to woe, how long will it take once you start physical decommissioning to completion?
Thank you very much. Should we take those two? So, cost savings?
Yeah, so I think there's many areas where cost savings can be made. It's fair to say we've been learning and improving as we've gone along. So as Duncan highlighted, the bulk of the costs in decommissioning are related to plugging and making safe the wells. And that's an area where there have been a lot of improvements. There's been technology improvements, there have been just improvements in terms of efficiency and understanding the task better. There's some very good oil and gas UK guidelines on how to do that now, which have been jointly developed between various operators, supply chain and the regulators. So that's improving, and that's very much the critical path through most decommissioning projects, is the plugging and making safe of the wells. And whilst you're doing that, you incur running costs on the platforms. So the shorter you can make that time, then the less your running costs as well as your cost of P&A, of plugging the wells. So that's a big area to, if you can reduce that time span, you don't have to run the platforms for as long.
Thank you.
And then I think we'll also, as the market matures, if you look at the Gulf of Mexico, there's sort of hundreds of platforms have been decommissioned there, and it's now a fairly routine commodity sort of market where the supply chain are doing a lot more and the operators are able to step back, and there can be cost savings associated with that.
And in terms of the period and how long it's going to take, who would like to answer that? Duncan, was that one for you?
So the project was initiated in 2006, so we've been doing it for 10 years already, and we've probably got another 10 years to go. It's kind of a question of what phase are you talking about? Because initially it's about setting up for efficient plug and make safe reservoir isolation. You're then in the phase of effectively focusing the platform on conducting efficient reservoir isolation, and then it's moving from that on to the engineering down phase and the final removal of the topside or anything if you're moving subsea installations. As Alistair said, the trick is to try and move seamlessly between each of those phases and trying to overlap the phases where you can do, so that you're maximising every bed on the platform and trying to conduct the activity as efficiently as you can do, whilst at the same time looking at the scope and seeing whether you can do the scope more efficiently, but also see whether you can develop new technology to allow you to do it faster, whilst at the same time learning lessons from others who may be in a similar position.
Can we, sorry, if you want to follow up, can you use the microphone, because we are filming this, so thank you.
I'll just get some clarity on physical timescale between go to well, i.e. when you start, and whether that means when a novice like me just cutting off a platform and moving it, and then deconstruction, or do you classify from starting from 2006? But at what point do you say, that's it, let's walk away from this?
Thank you.
So if you took, say, a typical FPSO, floating production storage unit type field with wells and subsea architecture, that might take 7 years, something like that, to do the wells, remove the infrastructure. Brent obviously added levels of sophistication and complication because we're still in production on Brent Charlie, and that means that from start to finish we've been about 20 years. But I think sort of 6-7 years is perhaps a typical field.
Thank you. Let's take the next couple of questions. There's a gentleman here, second row, and gentleman over there. Thank you.
Thank you. Neil Glover, GMOC Limited. If we're looking at the platforms, once you've removed all of the pipelines or taken them out of commission, you're going to, I presume, from what I read, was you're taking the complete jacket out, the Alpha jacket out above the pile clusters. But you're going to be left with the concrete legs without the topsides on. Is there any will you have to continue to do any maintenance, because there might be build-up of something like H2S in the shafts, which of course has been a problem in the past. And I see that the minimum life you say they will last is another 150 years. The opportunities for reuse, will they be kept open if possible? They may not seem economical today, but will they be possible? There may be something in the future. So what's Shell's plans for ongoing maintenance with any long-term issues and opportunities for potentially in the future?
Thank you. We'll just part that question from it, and the gentleman over there. Thanks.
Sorry. You showed the Frigg field there and what's gone before. I guess you've got others coming down the line like Brent Alpha. Just wondering whether there's been much sort of potential for collaboration with other operators in technology development or studies you've carried out, that kind of thing.
Thank you. Right. Post-maintenance and safety issues.
Yeah. What we'll do is we'll put a cap on top of the legs with nav aids. The nav aids will be changed out by helicopter or by a vessel with a long crane, if you like. We don't anticipate putting people back on top of the legs ever. We have cleaned the insides of the legs in as far as we can, removing any hazardous materials, and the legs are flooded now to LAT, so we don't expect build-up of H2S or anything else for that matter. When we'd plugged the wells, we did a monitoring phase, and that gives us some confidence as to that we've got good isolations from the reservoir. So I think as for reuse, we do remain liable forever. So I guess we would always be open to that. We will have periodic monitoring of the environment and the structures. That will be done on a risk-based basis, of course. But so I guess if there was a good reuse suggestion that came forward, I think we would be always open to discussing that and looking at it. So far, what's precluded anything like that is really the fact that the facilities are so remote that it's difficult to imagine what they could be used for.
Thank you.
And with regard to operator collaboration, there is currently an active decommissioning circuit where lessons are passed, both with other operators but also the supply chain. And there's also workshops and events with the sector bodies such as Oil and Gas UK or IOGP, where kind of nitty-gritty lessons are passed on. So in that respect, everyone sharing lessons that they've learnt and trying to learn from others is actively going on already. With regard to pooling activity, so you've got a wider pool of activity to do, it really all depends on the end of field life stage that your platform is at, and whether it makes sense to actually focus on it now in current market conditions, or whether it is worth engaging with other operators to see whether there is an opportunity to pool scope together. After the merger with BG, we have a reasonably wide portfolio of assets. So our focus is unfortunate from a Brent perspective that it is 4 platforms. We have the ability to learn lessons between those, but it's making sure that we pass those across the wider portfolio in both Shell and now kind of an integrated Shell and BG.
And Duncan, if there are companies or representatives or engineers here who might wish to collaborate or in some way, how would they go about that?
Well, as I said, Decom North Sea is probably the first point of call. It's a sector body which is focused on decommissioning in the North Sea. It's it's very active in ensuring that everyone understands what the opportunities are and how to engage with the supply chain operators to take advantage of those opportunities. That I think is probably the first obvious point of call I would suggest.
Okay. Thank you. Gentleman in the middle there. We'll take another 2 more then for now, and gentleman there at the bit. Thank you.
Thank you. Martin Whalen from the Health and Safety Executive. Obviously these platforms have been out there quite some time and have gone past their original design life. Are there any plans to recover any material and subject them to testing to see what long-term lessons you can take forward onto your other installations worldwide that are probably not anywhere near the decommissioning dates yet?
Yeah. Thank you for that. And a question here.
Just following on from that question, I'm Steve Jenkins from BP. Is it feasible to salvage and reuse any high-value equipment, or is it economically unviable to do so? If so, what type of equipment could be reused? For example, valves, actuation.
Okay, 2 really good, quite related questions there. We'll take one. Is there another question? The gentleman here, thank you.
My name is John Dyson from London Business School. Thanks very much for the presentation. It's certainly a mega engineering challenge. Also, clearly a mega cost, and I'm just wondering right now whether it's a cost that Shell really wants to bear, given the depressing oil price scenario, and whether that means the project could be shelved, and whether that's a challenge from an engineering sense. Thanks.
Thank you very much. So,
I'll take the first two, and I'll leave the other one to Duncan. The sample questions is a great question. In fact, about 2 years ago, sat in a similar forum with the Institute of Structural Engineers who asked us that. So when we were drilling in through the concrete into the cells, we got some cores, and we've tested those, and that's provided real concrete data, if you like, but it shows how the concrete has aged. And that gives us real data that we can put into the models and give us a better understanding. And in general, when we've talked to our stakeholders, we've tried to do that sort of thing where we can. To try and increase the knowledge base, because that's important to some of our stakeholders. On the question of reuse, reuse is desirable, higher in the waste hierarchy than recycling. And our contractor, Able UK, you will, in that soft strip phase, go and see what they can salvage, so that they will look at things like valves, actuators, there's some plate heat exchangers made of titanium, those sorts of high value items that are worth removing. They're also very good at identifying structural steel sections that can be used or reused, so they've done that in the past. The BP's Northwest Hutton platform, the module support frame from that was, the whole jacket was decommissioned at Able's facility. They kept the module support frame, an enormous piece of steel, about 50 meters high, in fact, and that they kept that for years. And it's actually now been bought by Allseas and made into the test lift platform. So they are very good at identifying things that have high value, and they'll certainly be looking to do that before, so it's reuse before recycling.
and is that spawning new business, that part of decommissioning?
I think there's an appetite to do more in the reuse phase. Obviously, reuse of valves is something that could be done. Valves can be relatively easily moved and refurbished, and their integrity verified. It gets a bit more difficult with other things, but I could see as the market picks up, and don't forget we're in the infancy of decommissioning at the moment, so there's been really probably only about 20-30 projects in the UK spread out over a long period, so the volume of material has been relatively low. But in the Gulf of Mexico, whole topsides have been recycled, reused, I should say. So.
Thank you.
So on the question of cost, it's relatively straightforward. There's a regulatory requirement to decommission, and we are liable, through regulation to conduct that activity. There's an increased focus from a oil and gas authority perspective on delivering efficient decommissioning and ensure that is being conducted as efficiently as possible. That's one of the reasons why, from a project perspective, developing new techniques, technology and sharing lessons is really important to us. But also one of our project lessons is actually kicking us into the long grass and trying to delay work is actually causing more problems, because you end up sitting on a platform which is older and older, and the integrity of the platform is more in question. The capability of the platform to conduct the high cost plug and make safe activity is only going one way, and that's up. And one of our lessons is, whilst a platform is still running, that's actually the time that you should be getting on and conducting the activity which is the highest cost. That for us means trying to, once you start the plug and make safe system, trying to reduce the duration of that, and as Alistair said, reduce the operating cost by doing it. That's really the key focus.
What do you assess as the level of risk of cost? You must have done forward projections, and the inference in the question is a really important question, is you have to make a balance between future cost, technical risk, and in the end, shareholder dividend. And you have to balance all of that. We talked earlier about the level of public confidence in this, and the balance between your cost and risk and shareholder dividend. So how is that being managed within the company?
You may not be surprised to hear there is a focus both internally and externally on cost and driving the most efficient decommissioning program you can do. But you also saw from that there's elements where the regulation is pretty clear about what you need to do, and we're also liable in perpetuity. So it's incumbent upon us to get that right and do it in a manner which means we're not having to come back to the platform and revisit the wells once they have been plugged. So we understand that now, and the focus is not about trying to delay it, but about actually trying to get on and conduct the activity.
Okay. And do you want to add anything to that, Alistair?
I think it's worth saying that the regulator, the new Oil and Gas Authority, they've been set up with a remit to do three things: maximise hydrocarbon recovery, protect the infrastructure, and reduce the cost of decommissioning. So there is enormous interest from them to drive down the cost whilst not compromising safety in the environment. So they very much look to us to do decommissioning efficiently. And so, as Duncan says, for us that is actually keeping up a reasonable tempo. There may be other projects where it's possible to come to a certain point, perhaps plug and make safe the wells, and then leave say subsea manifolds and things like that later, and come back and do them in a campaign with other operators or with your own stuff. So being efficient is the expectation from the regulator.
Okay. There you go. Thank you for that. Next question, please. There's a gentleman at the back there, and thank you.
Yeah, good evening. My name is Matthias. My question is centered on waste management. Considering the fact that the huge structures will be left under the subsea, has the stakeholder, in particular Shell, consider factoring the implication that such will cause to other marine users? What we're discussing presently now has to do with the knowns, but we need to look at the unknowns. What impact will the subsea that will be left after the commissioning process will have other sea users or marine users in future? Thank you.
Interesting question. Thank you very much. And gentlemen here, please. Thank you.
My name is Paul David. I'm a safety engineering and risk management consultant. We were talking about the regulations. As you know, safety case regulation, July 2015, brought in extra requirements for the safety case. Now, as you know, we have to incorporate a lot of environmental issues into the safety case. So don't you think that this process will delay the Brent commissioning project and bring in more challenges? Because the way I looked at the safety case regulations, revised safety case regulations, they want the DEC wanted more and more environmental data, more and more environmental regulations to be complied with. So do you foresee any further delays in getting approvals?
Again, two fairly related questions.
Well, let me have a go. So I think the question from the back was, so have we thought about the environmental impact of the things we're leaving behind? So very much that's been a part of our work, is to look at the whole environmental impact of what we leave behind, as well as the operations that we carry out. And so leaving clean steel and clean concrete, it isn't really an environmental hazard. And in fact, there's a lot of work in academia now, for example, Professor Lindeboom at Wageningen University in the Netherlands, actually saying that clean steel and clean concrete could help recolonize the North Sea by allowing species to progress back to where they've been removed by overfishing for over 100 years. So the environmental impact assessment that we've done for the whole project was done by DNV. Very comprehensive piece of work. We have Fred Decellier and James Blackburn from Fred's our cell remediation specialist, and James is our overall HSE manager. We can take you through that afterwards if you're interested. I think on the question of the safety case, we have an approved safety case for the removal of Brent Delta. It covers the whole period from when we deman the platform through the lift, the transport to shore, the load-in and the dismantling. And again, we'd be more than happy to talk you through that. It hasn't, the change in the HSE regulations, HSE safety case regulations hasn't unduly caused us any issues. Yeah, James, I'm happy to talk about that later. Yeah.
Thank you for those two questions. Next questions. A gentleman in the middle here. Two gentlemen in the middle here. One behind, and then gentleman in the white shirt just here.
I am Zimmer Coley, Upstream Advisors Limited. I'm just wondering what the impact on jobs would be from this project, because obviously from a positive standpoint, there will be new jobs created in the decommissioning industry. I'm just wondering what Shell's approach is to existing employees on these platforms and other fields that will be decommissioned in the next few years. Is there scope for retraining them, to redeploy them to decommissioning? What's the overall impact in jobs?
Thank you for that. Sir, you're...
Good evening, my name is Andreas Rothman. How does the cost associated with the recommendations made compare against the assumptions made in the original investment appraisal back when the platforms were sanctioned?
Thank you for those. Jobs first? Jobs? Lots of jobs?
So the jobs, there's about 1,500 people currently working both onshore and offshore in the Brent Decommissioning project. As I said before, we've probably got 10 years still to run, so this isn't a kind of an overnight process. And as you see, we have 4 platforms to decommission as well, so a lot of the work will focus on one platform for one specific type of work, and then move on to the others. We have a blend of both Shell staff and contractors. And from a contracting perspective, clearly those contractors can move on to other decommissioning projects, having gained experience and skills in the Brent project. And from a Shell perspective also, those who have been working on the platforms have also the ability to move between the Brent platforms, but also out into the wider portfolio. Some of the personnel who work offshore have been with the platforms throughout the whole life cycle of those platforms, and in fact they will retire when the platform is finally demanned. So for some of them it is literally the end of their career. It's a natural point in that career to cease working, and for those others it's a chance to take the end of field life lessons from Brent and move those onto other platforms.
Thank you. Costs. All on costs.
Costs. So I think the field has produced far more than we ever expected. So we've produced about 3 billion barrels of oil equivalent. It's about 8% of the UK total. So it's been a prolific field. We call it a prolific national asset because 70 pence in every pound of revenue has gone to the government. So even after taking the cost of decommissioning into account, 20 billion pounds has gone to the Treasury. So that gives you an idea of, I think, of the economics. It's, is vastly in the credit of the government and the people and the investors in the field.
Just on just to return to the issue of jobs, if I may, something the institution is very keen on to ensure that the professionalism and training and continuous professional development of engineers in the industry. Do you see the universities, for example? I noticed that you had the University of Aberdeen as one of your stakeholders, and I know you're involved with many other universities as well. Are the universities and the colleges of further education providing the sort of skills that you need, or do you see this as a new area of, particularly new area of engineering?
But I think the fundamentals of mechanical engineering or structural engineering, those are the basic skills, and then you can adapt from that. It's the same with the trade skills, plating, welding, rigging, those sorts of things. We still need those people, and it's important, I think, that to say the North Sea is not dead. Even though we're going through a tough period at the moment with low oil prices, things will hopefully return. There will be project developments. There will be lots of decommissioning to do, so we're going to need a new generation of people to do that. So we will need all those skills. At Able, we are in partnership or looking at a partnership with one of the technical colleges there to have a decommissioning module. And indeed, many of the skills agencies are looking at that, sort of how do they tailor the existing skills to the decommissioning market.
I think one of the unusual things about decommissioning is, unlike the commissioning phase where you're spending a lot of money on cold steel, actually most of the spend in decommissioning terms is spent on hot bodies, on people offshore or onshore actually doing work. So in that perspective, generating the skills and experience is really useful, because then you can roll onto other decommissioning projects. And the skills and the kind of technology is not too different from what's used during the production phase. I think what we have, one of our lessons is actually a mindset change, thinking slightly differently about the problems and making the solutions that the engineers are coming up with fit for purpose for decommissioning. So not coming up with solutions to provide a capability offshore which is going to last for the next 25, 35 years, when actually we know that the platform's only got 2 or 3 years left before it's finally removed. So it's a shift in mindset, which is actually one of the kind of key components and the key lessons from our perspective.
Yeah, so I think behind all this is we talked about recycling of materials. There's also recycling of the skills and the lessons learned, and it's not just technical, it's environmental and of course risk assessment. It's the safety lessons that you're learning, which, as you said earlier on, a lot of it is groundbreaking. So how are you recycling that back into the education system and skill system that you need?
Well, we're active on all of the decommissioning conference circuits. We regularly talk at all of the decommissioning conferences to ensure those kind of key lessons are passed on. We do have an engagement with academics there's an increasing focus from an academic perspective on decommissioning, and so we do have engagements with academics to ensure that those kind of key lessons and the kind of key points that we're bringing out do get kind of picked up by the academic community, and then cross-fertilised with other decommissioning projects to understand what are the key lessons.
Yeah. Okay. Thank you. Thank you for that. The next question, one in the front here, and there's another one at the. Let's take the one at the back. There. We'll come back to you in a minute, sir. Okay. Thanks. Gentleman with the beard up there in the back. Thank you, sir.
It's Ian Ashcroft here from Arup. I was just wondering if there've been any lessons learned and what can be done in the design of new platforms to make them easier to decommission.
Thank you for that one. We'll take that question up there. Thank you. You're being attacked from both sides, by the looks of it.
Hello, I'm Alex. I work in defence. That was fascinating. It's all very new to me, so I apologise if it's slightly naive questions. I'm interested in the gravity-based structures and your decision to leave them where they are. Is the problem that there's going to be this structure protruding out of the sea, causing an obstruction, or are they going to decay over time, cause contamination? And when you looked at how to get rid of them, if they were on land, you could conventionally use explosives to take out a structure like that. How did the use of explosives factor in your options to take them out?
Would you like to answer that one first?
Or? Yes, the legs will protrude above the surface of the sea, and in order to understand what the impact of that is we commissioned a study to understand what the hazard, what the collision risk to that was, and it was about one collision every 10,000 years, so well under an ALARP level. And that assumption is very conservative because it makes no allowance for an uplift in technology over time. So if you can think about the last 15 years as we've had kind of GPS technology starting to be developed, the assumption based on that very low collision risk makes no assumption for an uplift in technology. And of course, The main the two main users of the sea up in that area are, first of all, those related to oil and gas, and that will decline. But secondly, the fishing industry. When you engage with the fishing industry, actually their preference is leave the legs up. What you can see, you can avoid. We remain liable in perpetuity. So whilst in a kind of period of 200 to 250 years, the tops of the legs will fail at sea level, we remain liable to ensure that they are marked. We also, in addition to making sure they're marked in charts and ensure that they're marked with aids to navigation, they're also marked within the fisherman's fish safe system. So they have an alarm system in the cockpit in the cabin of the fishing vessels, which enables them to have an audible alarm when they get close to decommissioned infrastructure to allow them to steer away. Actually, when you talk about when you talk to the fishermen, they're probably looking at unmanned fishing vessels in that duration far out. So that's kind of the first part of your question. With relating to explosives, yes, we did look at the use of explosives, and whilst explosives aren't prohibited for decommissioning, there are some quite tight guidelines under which you need to operate. The concern from a leg perspective is if we were to cut the legs, we needed to cut them at minus 55 metres to adhere to International Maritime Organisation guidelines. That's an 18-metre diameter cut you'd have to do, and then, having made the cut, conduct a 6,000-tonne lift. Well, when you conduct a cut like that, you need to be absolutely sure that you've gone all the way through the structure, and the problem is with explosives is you can't necessarily guarantee you've severed the rebar, and that's kind of high-level overview.
Yeah, I mean, just to add to that, I think when you see a tower block come down, you need to place explosives on virtually every floor and drill it into the concrete structure. So if you did that with the leg, you'd be doing a huge operation of drilling and adding small amounts of small charges all the way up. So that, coupled with the noise to marine mammals, it probably wouldn't really be a viable option.
Okay, thank you. And lessons learned.
In terms of new platforms, since the mid-90s, offshore oil and gas facilities have been designed with removal and decommissioning in mind. So there aren't too many concrete gravity-based structures, but occasionally they are used in areas where there's a lot of ice. So Shell have one in Sakhalin in Russia, and that's been designed to be refloated as an example.
Thank you. Okay. Next, there's a gentleman up there at the back, and a gentleman down here in the front row, please. Thank you.
Yeah, thank you again. My name is Matthias. My question is centered about cost again. We know in every project there's bound to be accidents, and in the case of decommissioning, it's a very gigantic operations. If for any reasons there's this unknown situation where spills actually occurs on the ocean, who actually is going to bear the cost? Because I'm aware that the UK government is going to fund 50% through tax rebates. And I know Shell equally, or the operators are going to have 50% of the cost in decommissioning. But if for any reason there's an accident that occurs in the process of decommissioning on the sea, who is actually going to bear the extra cost? That's my question. Thank you.
We'll just take that one first, then come back to the gentleman down here.
So,
very interesting question.
Yeah, so obviously, as the operator of the field, our prime concern is to do things safely and environmentally responsibly. And we go to a huge amount of effort every day to do that. So in the first instance, if there was a spill or something like that, it is the operator who is accountable through the courts and through the various sort of statutory tools. So the costs of that, I think, that's probably one of the last things we think about when something bad happens. Our first concern is to make sure it never happens again.
Right, gentleman here, thank you.
Hi, I'm Matthew Stevenson from Suez. With a 20-year project lifespan and a world where technology is changing all the time, how do you make sure that you're not missing out on technologies or innovations that could help the project and save money?
It's a great question. So I think you've got to be externally focused, continue to listen to good ideas, continue to talk to the supply chain. I think probably we need to get slightly better at describing the problems and challenges we have to the supply chain rather than asking for specific solutions. But over the course of this project, technology has changed, and that we have had to go back and rethink things. And I think that we're probably not at the end of that. So, and I think under the regulations, we will get hopefully an approved decommissioning program. But if technology changes, we can be asked to come back and review it, and if necessary, make changes.
Thank you. I think we've probably got time for one more question to take one from the audience. A gentleman up just up there on the back row, up there. On the back row up there. Thank you. In the light shirt.
He's scratching his head now, so think very quickly.
Hi there, it's Tim McClelland. I work at Mars Chocolate. A question around the regulations. You said that you've been trying to meet the regulations and in some circumstances obtaining derogations. Is there any way where you've gone over and above to meet your own ethical standards?
So I think actually our ethical standards are pretty aligned with the regulations in place, and a comparative assessment is a useful tool to understand what on balance is the right thing to do, weighing up a number of different options. So it is understanding the impact to society, to the environment, to the technical feasibility of what's being conducted, safety and cost. And I think those are useful benchmarks. But in addition to that, we've stress tested, and whilst we've weighted each of those equally as a starting point, we've then stress tested the comparative assessment by overweighting one to see whether you'd come up with a different conclusion if you were to overweight one by 40% and underweight the others accordingly. And actually doesn't change the overall outcome from that comparative assessment process. What we have been pretty thorough about is that stakeholder engagement process to ensure that we have been as diligent, as open, as transparent, and as thorough as we could have been over a protracted period of time. We've got a website where you can read as much or as little as you want to on Brent Decommissioning on that website, and we've put as much information on that as early as we possibly can to ensure that we are being as transparent as we can be, but also take questions from those who send them in, responding to the website, but also we're usually pretty quick to respond to requests for one-to-one engagements to talk to people. So I think the process itself is pretty closely aligned, I think, to Shell's ethical standards anyway. So it hasn't required too much, if any, adaptation.
Okay, well, thank you very much indeed. I'm going to draw proceedings to an end. I'd very much like to thank the IMechE team here for organising the evening, especially also the Shell team here for all your support. I'd very much like to thank you all for attending and for some really interesting and insightful questions. Thank you very much indeed for doing that. And finally, I'd like to thank on your behalf our two speakers for a really interesting insight into the scale of this technical challenge that Shell is facing, and for bringing to us all a really well explained and very clear exposition of what you're up to. And we wish you very, very best of luck in what is going to be an enormous industry with huge challenges, but also enormous opportunities for the next generation of engineers. So thank you very much to you all. I hope you enjoyed the evening. Thank you. Thank you very much. Thank you. Well done. Thank you very much.